All right, picture this. Our universe is so unimaginably huge, it's honestly a bit overwhelming. Even if I found another Earth-like planet in a distant galaxy using the most powerful telescopes, it would take me, well, lifetimes just to get there. The closest galaxy to us is Andromeda, about 2.5 million light years away. If I took a regular spacecraft at 28,000 kilometers per hour, the journey would take 94.5 billion years. Even at the speed of light, I'd still need 2.5 million years. That's pretty discouraging, right? So what's the point of discovering new worlds if I can never visit them? Well, what if there was a shortcut, a real sci-fi style portal that could get me across the universe in months instead of millennia? Enter wormholes. Now, wormholes aren't just a wild fantasy, they're actually rooted in Einstein's theory of relativity. Let me break it down. Einstein's field equations describe how matter and energy curve space-time. Imagine space-time as a giant, stretchy mesh. Heavy objects like stars and planets bend this mesh down, creating curves and dips. When Einstein and his colleague Nathan Rosen solved these equations back in 1935, they found a solution now called the Einstein-Rosen bridge, or what I'd call a wormhole. Think of it as a tunnel, a shortcut connecting two distant points in space, almost like folding a piece of paper so that two dots touch. Instead of traveling across the whole sheet, I'd just poke a hole through. Here's where it gets even cooler. If wormholes exist, they could connect not just places, but times. I could, in theory, use a wormhole as a time machine. But there's a catch. Creating or even keeping a wormhole open may require massive amount of gravitational force, like what you'd find near a black hole. And that's another twist. If the exit of a wormhole is another black hole, I'd be completely trapped. No way out. So what's needed on the other side is something totally opposite, a white hole. White holes are a theoretical flip of black holes. Nothing can enter, but energy and light can escape. But here's the reality check. So far, wormholes are just a mathematical solution. No one's ever seen one for real. But remember, black holes were once just theories too, until scientists snapped their first picture in 2019. In 2015, scientists even managed to create a sort of magnetic wormhole in a lab. Not with gravity, but with magnetic fields. It's not quite a gateway to another galaxy, but it's a start. So, will I ever be able to leave the Milky Way? Maybe not tomorrow, but the universe is full of surprises. If wormholes, white holes, or even faster-than-light drives become practical, who knows? The next great shortcut could change space travel forever. Until then, I'll keep dreaming. And maybe, just maybe, science will catch up.